Okay, so what has this got to do with computer science? Well, one thing is it's actually exactly the way early computers would search for data. So we said it's an algorithm, and it turns out that exactly the same algorithm that works for tricks actually works for finding data on punch cards. So what are punch cards? They're things that look a little bit like this. So here's a larger version of one, and what you have is a binary number written across the top. So in this case we've got the binary number 17. So 17 is the data on the card. How do you make that in binary? It's a 1 in the 16 column, no 8s, no 4s, no 2 and a 1. 16 plus 1 makes 17. If we take a different card, the number 8, and 8 is no 16s, 1 8, no 4s, no 2s and a 1. Taking yet another card, take 15. 15 is no 16s, an 8, a 4, a 2 and a 1. 8 plus 4 plus 2 plus 1 makes 15. So you spell out the number in the slots. A 0 is represented as a whole, a 1 in the binary is represented as a slot. So how does this work then? Well, it can then be used as a search algorithm, doing exactly the same as the down-under deal. So what did the down-under deal do? It threw away every second card, and you were left with one card, 16th card. So what you have to do the equivalent thing with punch cards is spell out the binary of whatever number it is you're looking for. So if we want the number 16, in binary, number 16 is a 1, and then no 8s, no 4s, no 2s and no 1s. Okay, so we spell that out starting from the 1s. So what do? Put a pin or a pencil in the end and shake out all the cards that have a 1 in the binary. And which cards are they? Well, actually it's 15 and 17 and 1. It's all the odd numbered cards, because that's how in binary you get an odd number. The only way you can get an odd number is if you have a 1 in the slot there. So all of those cards go. And what we're doing is using the binary as a code. So we're after number 16. So whenever there's a 0 in the binary, you discard the down pile. You throw away the cards that drop. So we can then go on to the 2's column, and there isn't a 1 in that position in 16. So to end up with the 16th card, we shake those out and again lose the down pile. And which cards disappear? It's exactly the same ones. These time they're even ones, but it's the same cards that were thrown away in the second round of the down under deal. We then move on to the next pile and shake those out. And again, we're now in the 4 position in the binary, and if we're spelling out 16 in binary, that's a 0, so we throw away the down pile. We do the same again for the 8s and throw them. And then when we get to the 16, there's a 1 in the binary of the 16, so we'll keep whatever drops at this point, and what drops is the 16th card. And that's exactly the same thing, the same algorithm, just done in parallel, that was happening with the down under deal. And all we're doing here is applying that algorithm on the cards. And that was how we got the 16th card, but we could actually do exactly the same thing to find any card we wanted. So if we wanted to find the card 5 out of the pile, what do? We spell out 5 in binary. So 5 in binary would be 1 4, no 2s and 1 1. So if there's a 1 in the binary, what that means is we'll keep the down pile if we're after a card with a 1 in the binary. So this time we keep the down pile and throw away the others. There's a 0 in the number 5 in binary, so this time we'll discard the down pile. So we shake them all out and discard the down pile. And there's a 4 in the binary for 5, so we'll keep the down pile this time. So we shake them all out, and this time we keep the down pile and throw those. And next it's 0, so we'll throw away the down pile. And then we'll go to the 16 and throw away the down pile, and we're left with only one card, which, because we've spelled out the binary for 5, we're left with card 5. And so it's actually an algorithm for searching for things. We can take a pile of cards and pick out any card just by spelling it out in binary. Each time we shake through the cards, we're doing one round of the down-under deal. Each time we're throwing away half the cards that are left. And it's exactly the same set as we would be in the down-under deal. So that shows that actually the magic tricks and computer algorithms, they're not just the same general idea. Exactly the same algorithms can be used in a magic trick as are actually used in real applications in computer programs. When you code them into a program, that could be a way you could use to find data out of a stack of data stored in memory or on punch cards. So magic actually is the same as computer science. Magic and programming are the same. Thank you.